Hello everyone. Today we are going to discuss about charge coupled device CCD cameras. I'm going to explain the structure, the science behind CCD cameras, and I'm going to go step by step how exactly photons are converted to electrons and then how those electrons are being read out by the detector. This is what you see is the chip, the CCD chip, the camera. You can typically see it inside the devices. This chip typically made of pixels. As you see, each of these rectangles, they're called a pixel. So I'm going to go ahead and then write. So these are pixel. And the devices, some devices, they have thousands, 10,000s. Some of them even have hundreds and thousands and millions of pixels that are within this one chip. It's a very, very teeny tiny small. So let's take a look how exactly those pixels work and what they're made of. So they typically, they're responsible to collecting a photon and then converting that photon into electrons with the theory called photoelectric effect. So when we enlarge one of these pixels, so when we enlarge this, we should be able to see a few layers of this when we try to like flip it and then see from the side. First we see a substrate. A substrate, it's called a p-type silicon. It's made of silicon. So these kind of substrates they have. So I'm just gonna go ahead and write this is p-type silicon. Okay, so on top of the silicon there is a, silicon dioxide insulator there. So insulator is somewhere on top of that. I apologize for the noise. On the top of this p-type silicon, and on top of the insulator there is a thing called gates, and those gates are made of polysilicon. So we have p-type silicon, we have and they also called n-channel insulator, n-channel insulator, and on top we have gates. So these are gates. I'm just going to write in a singular form. The gates are made of polysilicon. Okay, so what exactly they do? How exactly they work? In p-type silicon, they can apply the potential and they can make a wells. The well is it's like a bucket or it's like a jar that is inside this p-type silicon, something like that. It's like a little hole there. Why do we have this? These holes are responsible to collect the electrons. So where they get the electrons? The electrons are formed from the photons. Where does the photon come? The photon comes when we take a picture. The light will hit this gate, and then when it hit gates, it converts the photon into electrons. And if you could see my previous videos, I'm going to attach it on my comment section. The photoelectric effect. It was first introduced by Albert Einstein. So I'm just going to quickly draw this. So Albert Einstein, based on that, there is a metal. When you apply a light or photon is a light. When you apply the photon in certain energy, energy is equal to h nu. What happens is, when you match the certain energy of the metal, so it can extract basically electron out of this metal, and this is what we call photoelectric effect, introduced by Albert Einstein in 1905. So the CCD also works under the same theory. So when the light comes from the top right here. When light comes, of course it will carry the energy, EH nu. H is the constant and nu is a frequency. We can also convert it into wavelengths. In certain wavelengths into certain energy when light hits. So what happens is, based on photoelectric effect theory, it converts the light into electrons. And when does it do? The electrons, they're gonna be generated right here. They're gonna fill this well, the electron well, which is located on the p-type silicon. So this is how each pixel work. And of course there is a voltage associated here, so the potential will be applied. Here, and that potential, the positive potential, they're gonna pull that electrons, because electrons are negatively charged. They're gonna pull it, and that's how they temporarily store it inside these wells. Well, so this is how each well, they're gonna collect the electrons, and as you know, based on photoelectric effect, one photon will generate one electron. Once the photon is collected and it's converted into electrons, then further it's going to happen a readout. So how exactly the device is going to read each of these photons or electrons and then further convert it into the signal. So next, what happens after collecting a photon, each of these pixels convert photon into electrons, and then what happens? Then they start moving, of course, with the potential, with the applied. They have this whole system also has a potential which can apply. When we apply the potential, the charge is going. This potential is going to drag the charge. So where exactly it's going to drag the electrons? It's going to drag the electrons, we say, horizontally in this way. So if there is electron right here, a photon converted into electron right here, the potential also is going to drag them towards, horizontally, towards this device. This region is called the serial reader. So here, when it reaches the edge of this the device, then it's going to store the electrons right here. Then this called serial reader is going to collect all these electrons. And what happens after this? After this, then the different potential or different voltage, they're gonna drag the electrons now horizontally. So first, it's vertical electrons that are generated by photoelectric effect from the photons, first dragged from the vertically at the edge, and from the edge they start dragging it horizontally. So where does it go? Horizontally, this is connected to the analog to digital digitizer. So analog to digital signal converter. So electrons, first they're gonna be converted into voltage. So just say voltage. And then from the voltage, they're gonna they are digitized. So analog to digital converter. There is also amplifier there. So when they convert, and that will generate a signal. So the important part of this CCD is how exactly it collects the photon and transfers that photon, the collected signal, towards the detector, towards this readout. So first it collects it, converts the photon into electrons, then electrons will be moved, will be dragged across the pixels and at the edge, and at the edge they will be transferred then horizontally towards the analog to digital converter, which then eventually it produces the signal. So we can also compare this into, we call it bucket brigade. It's the same thing as when people are carrying the bucket, the water inside the bucket, and then they one by one they're carrying the water from bucket. Like one bucket is here, and then they transfer it here and here and here across vertically, and then they fill this bucket right here. This also served as a big bucket, and they put the water here, and then eventually that bucket is gonna move horizontally towards here, towards the main collection point of the water. So the CCD, charge coupled device, also work under the same theory, under the same concept.